All right, welcome everybody. Welcome on in. Going to talk about some Math 3 today, so intermediate algebra. So the stream is up. There's about 10 people in there right now. So someone's asking about the YouTube stream. It's up and going. There's 12 people in there, it looks like, at the moment. So you should be able to get in there. If you use the link from the class meetings Canvas page, it should be able to take you there. And then when you show up on the YouTube page, it should show you streaming now or something like that. And if you click that, it should let you in there. So I'm answering that question. Anyone's welcome to stay in Zoom. I'm only bringing that up because someone's asking me a question about when the live stream will start. So it's up and going. But as always, you're welcome to consume these meetings whichever way you prefer. I am going to be covering some homework problems today, and it would probably be helpful for you to be able to see the problem behind me as I'm going over those homework problems. So there's a number of homework problems. Well, the first one I've had some questions about, so I want to go over that. And then there's some other homework problems that I've picked out that I want you to definitely be able to do. So before I get into those, is there any questions before we start? Seems like people are doing homework and making progress. Everyone's at a little bit different place, but overall, I think the class is doing well. So is there any questions? People still confused about the setup of things, or are we good to dive into stuff? We're good? Okay, well, if you have any questions throughout today's lesson, feel free to throw them into either chat, YouTube or Zoom. Throw them in that Zoom chat or live stream chat, and then I will definitely try to answer those questions, okay? So the first question I wanted to get to, and let's see, I got to make sure I do this without, I think I got it set up, without exposing anyone's stuff here, was these graph stories. So I had a couple of questions on this, so I thought I would cover it because if I had, 2 or 3 people asking me about it, that probably means that there were more people in the class who were confused by it, and I wanted to make sure I cover that so that people know what's going on. This is a confusing problem, right? So you want to make sure that you take your time with it, right? You're going to get tired of me saying this the whole semester, but it's that whole idea of go slow to go fast. You don't want to rush through a problem like this, or you're going to make a mistake, and then you're going to have to go back, find your mistake. That stuff all takes time. Do watch the help video, right? I'm not amazed with the font that they used for this. It's almost kind of it's not quite Comic Sans, but it's something a little... it's one of those fonts where it's easy to ignore. There's certain parts of websites that our brains are just we just ignore naturally, right? Like usually on the right there's some ads and we just kind of start to ignore those. We don't even look at those ads over there. This is another one that I think sometimes even a month into the semester I'll have students saying, wait, there's videos on the homework? Yeah, so make sure you watch the help video. If you're struggling on a problem, make sure you watch those. Very, very, very helpful. And then up here you have show example and see solution. The see solution is kind of the same as getting it wrong, so you might as well try. But the show example can be helpful. And then also some students are confused about the score versus the record. The record, it's almost irrelevant. You don't need to know. But the score is how many points you need to get on that topic before you go on to the next topic. So like a homework might consist of, usually it's somewhere between 3 and 8 topics. And Delta Math will keep giving you problems until you've proven that you know that topic, that you've understand that topic and can move on to the next one. So what you need in this case is you need 5 points. So that score will go up and down depending on whether you're getting problems correct or incorrect. So if you check your problems before you put them into the computer, then you're not going to get as many penalty points. The penalty is 1 off. If you get 1 wrong, you lose 1 point from your score. So in other words, once you do 5 of these correctly, if you do 5 straight correctly, you get to move on to the next topic. Okay? Otherwise, if you get 1 right, get 1 wrong, get 1 right, get 1 wrong, get 1 right, get 1 wrong, you're going to do a lot of problems before you finish. So the best way to do that is just double check your answer before you put it in there. Okay, so this has caused some confusion with a number of students, and it makes sense because reading mathematics in text form and converting it to algebra form or graph form like we're doing in this particular problem, it's not the easiest thing in the world to do, right? The English language has lots of different ways of saying the same things, and it has lots of ways that sound very similar but actually mean different things. So this really takes a lot of critical thinking, right? It's that critical thinking component. It's that logic component, that reasoning component. You can't just memorize that, right? The way you can memorize how to factor a polynomial, that some of you will do later this semester, or hopefully everyone learns how to do that later this semester. You know, you can kind of just memorize that process. Reading a paragraph and converting it to math, you can't just memorize because everyone's a little bit different. Every problem is a little bit different. And in this one, you can see there is a lot of information packed into that paragraph. I mean, that's one paragraph. It's what, 1, 2, 3, 4, 5, 6 sentences. 6 sentences isn't very much, right? But in mathematics, that 6 sentences holds a lot of information, right? If you go read a 6-sentence paragraph in a history book, it might tell you like where stuff's taking place. This is taking place in Gettysburg, right? That might be what you get out of the first 6 sentences. Not a ton of information being conveyed. In mathematics, usually when we write things out, every word is important. If you take away like 1 or 2 words, it's going to change the meaning of that thing. So you really want to take your time and read it carefully, and it's still easy to make mistakes. When I had a student in my office the other day on Monday office hours, and I was helping her with this problem, and the first time I did this problem, I messed it up because I misread one of the sentences, and then I made my line at the end wrong, and so, you know, then it marked it wrong, right? So it's very easy to make a mistake when you're reading this. So you want to take your time and just break it down. So I want to walk through one with people so you can kind of see how this is. So Hudson left his house at time 0 and drove to the store. So first we want to make sense of this graph. Oops, it's not going to let me scroll. Let's see. What if I do this? And then, okay, I'll have to do that. Okay, that works. I was making the window too big. I actually want to make it smaller. All right. So if we look at our graph here, it tells us, this is why we always label graphs, right? When you take statistics, especially if you take statistics with me, but really if you take any statistics professor, I'm going to say when you make a graph in statistics, it better be very well labeled, right? Which is a thing that people like to do, is leave off units, leave off descriptions, leave off labels. You got to label them, right? Because otherwise, how do I know what's my x-axis and what's my y-axis? Well, looking here, it's labeled. Oh, time in minutes is along the bottom. So these numbers along the x-axis, that's minutes. Those are time in minutes. How do I know that? It tells me right here, right? That's why in statistics, you make a graph that has no labels. You give it to someone else, and they go, this doesn't mean anything. This is just a drawing that you made, right? You have to label things properly. Over here, we have what? This is distance in blocks from home. So notice that they did 2 things here, and this is what you should do in your stats class. I've labeled this axis not only as distance, but also the unit that we're using, blocks from home, because there's lots of ways of measuring distance, right? It could be blocks, it could be meters, it could be miles, right? Lots of different units. We need to know which one. So they label it blocks from home. Same thing down here. Time could be in seconds, minutes, hours, days, weeks, months, years. There's lots of appropriate time units that you'll see at different times, but we've specified, we've made it very clear. We're talking about time in minutes. Okay. And also, this might seem like, okay, yeah, you know, I kind of get what's going on, but there's actually more going on here than you think, because this distance, that distance is different than distance traveled, right? If we made this total distance traveled, our graph would look different than here, because this is saying the distance from home, blocks from home. So, you know, as you increase your distance, your point's going to go up on the y-axis, but as you return home, it's going to come back down. Whereas if you just do total distance covered, then it's always going to be increasing. So you have to read closely and think about what is that label really telling me? Otherwise, you can make the right graph for what you think the problem is telling you to do, but it's not what the problem's really telling you to do. And then, of course, at that point, you're going to get it wrong, right? So you want to make sure you're on the same page read those labels, okay? All right. Hudson left his house at time 0 and drove to the store, which is 14 blocks away, at a speed of 2 blocks per minute. Now, what I would recommend, this is what I would do. I'm not doing it now because I can only show so many things on the screen at once. But if I'm doing this problem, in fact, I did this in my office when I was helping the student the other day. I'm going to take each one of these sentences, and I'm just going to convert it to a little bit of data on my paper. So let's see. It's like notes. You're trying to take this paragraph of 6 sentences and boil it down into a few phrases that you can read and still get that same information. So what do we know? The store is 14 blocks away. Hudson is moving. It says it's a him, right? So Hudson's a him. He's moving away at a speed of 2 blocks per minute. Okay, I got to keep in mind 2 blocks per minute, 14 blocks. So if I'm going to cover 14 blocks at 2 blocks per minute, how long is that going to take me? Well, we've got that equation, distance equals rate times time. Our rate is 2 blocks per minute. Our distance is 14 blocks. So if you solve for t, 14 divided by 2 is 7. It's going to take 7 minutes to get there. So now you have to convert that into a point on the graph. So I go, okay, let's see, 7 minutes. Remember we said that the minutes was the x-axis. So I'm going to have a 7 for my x, and my distance should be 14 because the store is 14 blocks away. So I'm going to come down here. We know we're starting at 0, 0. Time 0, he's at his house, I believe, right? Yeah, Hudson left his house at time 0. And then we just made the case that at 7 minutes, he's covered 14 blocks. It's a little, yeah. The graphs are kind of small. It's easy to think you're on the 7, but you're actually on the 6 or something. So hopefully I don't accidentally just do this incorrectly. Let's see if I can make this a little bit bigger. No, not really making it bigger. Okay. Okay, so now the next step. Then he stopped and went into the store for 2 minutes. So the stopping, while you're in the store, you're not really increasing or decreasing the number of blocks you are away from your home. Sure, you could make the argument, if I'm at the front of the store, I'm 100 feet closer than when I'm at the back of the store, but that's negligible, and we're talking about the distance in blocks from your house, right? So the idea here that they're trying to convey to us is that the distance does not change for 2 minutes. So then I'm going to click here. For 2 minutes, there's no change, so it's a plateau. My distance from home has not increased, and it has not decreased. It's the same amount, okay? From there, he drove in the same direction, so we're still going away from the house, same direction, at a speed of 5 blocks per minute until he got to the bank, which is 10 blocks away from the store. So we're going an additional 10 blocks away, but we're doing it at 5 blocks per minute. So let's see, if I'm traveling 5 blocks per minute and I go 10 blocks, how long did that take me? 2 minutes, right? So 2 minutes, so I'm going to go over another 2. So I'll start here, I'll go over 2, and what did I cover? Another 10 blocks. So if I'm at 14, that should put me up to 24. If I did that right? He drove in the same direction at a speed of 5 blocks per minute until he got to the bank, which is 10 blocks away from the store. Yes. Okay. So then he stopped at the bank for 6 minutes. So now I'm going to get another plateau because I'm not increasing or decreasing my distance from home. So over 1, 2, 3, 4, 5, 6, and we have a line there. Okay. Then he drove home at a speed of 8 blocks every minute. Make a graph of showing the number of blocks away from home that Hudson is X minutes after he leaves the house. That's what we've been doing all along, right? So he drove home at a speed of 8 blocks per minute. Now, there's 2 different ways you can do this, and I kind of want to show you both. So let's see. I can just say, okay, if I'm driving back home at 8 blocks per minute, that means I should be losing Y values 8 for every 1 I go over. Right? So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, and over 1. That's 1 step. Do it again. 1, 2, 3, 4, 5, 6, 7, 8 over 1. Right? See how we're using the slope there? That's actually our rise over run. And then down 1, 2, 3, 4, 5, 6, 7, 8 over 1. And we got that. So that's a reasonable way to do that. And if I check this, it's going to say you are correct. believe, if I haven't made some kind of a weird error in here by being off by 1 because it's kind of small graph here. But that should work. So even if you have to plot stuff in between, it's going to mark it correct. Okay. Or what we could have done, let's actually erase these. What I could have done was thought about it the way using that distance equals rate times time and said, well, okay, so we can see that Hudson is 24 blocks away from home, and he's driving home at 8 blocks per minute. That should take him 3 minutes, right? So that means he should be able to cover this entire 24 blocks in 3 minutes. So I go over 1, 2, 3, and I do it that way. Those are both perfectly legitimate ways of reasoning through that last part of the problem, and they should both get you full credit. Okay, so let's just see if I did that right. Let's see if I didn't make a silly mistake along the way. I submit my answer, and it says, are you sure? Yeah, let's be daring. Let's go for it. Yep, got it right. Okay, and then notice what it does here. It's really, really quite nice the way they've set this up. It's color-coded, and then down here you can go through and see the reasoning. So if you missed the purple part, right, that's where you made a mistake. You can come down here and go, okay, how did they figure this out? How did they do this? Oh, I see. And then you can make it the same way. Okay, so that's how that problem should go. So I know a few students have been confused on that, and part of it is, I know, like I say, I made a mistake on the first one I tried the other day. It's a lot of information. It's very easy, even if you know how to do the problem, it's easy to make a mistake here. That's why you saw me when I was going over it. I even when I graphed it, I read them a couple times just to make sure, because reading the sentence an extra time or two is going to be quicker than me making a mistake and having to start all over again, right? Or redo the entire graph. Okay, so hopefully that helps. Let's see. Let's see. So I have a question here. I also have another quick question about how to write an equation from your point. Okay, that's great. So there's a student asking me a question about finding the equation of a line from 2 points, and that's actually one of the problems I want to go over today. So we're going to talk about that. So feel free to, when I'm doing that problem, which I think, well, let's go ahead and do that one next, since a student has specifically asked about that problem. Let's go over that one. I was going to do it later, but let's go over it now, because it's actually a really important problem. So let's go over it, and then if there are any questions while we're doing that, feel free to ask. And I'm not sure, in the question that's being asked, I'm not sure if the student is asking me about how to do horizontal and vertical, but I'll try to remember to talk about that as well, right? So we can talk about those. Okay, so let's do that one. So there should be one in here that does that. Let's go back. Oh, what is it? A line from 2 points. So finding a line from 2 points. This is a great problem. I actually love this problem, and I frequently put it on exams. Any algebra test I give that involves lines, you're probably going to see a problem like this on the test. And the reason is because you kind of have to know, like, if you can do a problem where you take 2 points and you find the equation of the line and then you graph it, you pretty much know what you need to know about how to deal with lines, right? Sure, there are more details along the way, but if you can do this problem, you've sort of shown that you have a functional understanding of lines, which is something that you need in really any future math class. Even statistics, you need to know how to graph lines. So this is a great problem. So write the equation of the line. Write the equation of the line that passes through -3, 3, and 4, -1. Okay, so they've given us 2 points. We want to find the equation of the line that goes through that. There's a whole bunch of variations of this that you see in algebra. Find the equation of the line that goes through this point and is perpendicular to this other line. There's lots of different things. But whenever you're doing one of these problems that says write the equation of the line and then they give you a condition, step 1 is always slope. That should always be your first step. One way or another, they gave you enough information in the problem to figure out the slope. And that can vary depending on how the problem is written, but that's always step 1. Find the slope. And then from there, they want us to, in this case, they're saying put it in point slope form. So here they've specifically told you point slope form. Remember what I was saying was the default should always be slope intercept form. So if it ever doesn't say what form to put your line in, use slope intercept. But here they're specifically telling us to put it in point slope form. So we want to go through and do that. That's actually a little bit of a strange way to do it, a fully reduced point slope form. But anyways, I guess they don't want to ask too much in this one problem. So let's take a look. That's points. Let's kind of think about what this even looks like. So basically, they're giving us the problem. Was it -3, -3, 3. So we have points -3, 3. And 4, -1. 4, -1. So just as a visual, this is what they're asking. We have 2 points here. You can't see them. 2 points. Let's make them the same color. Seems reasonable. We're given these 2 points, and we're supposed to figure out the line that goes through those 2 points. We need to come up with an equation for that. Now, in reality, you can use whatever form of the equation you like. In reality, I would probably use slope-intercept form, but point-slope form, some people prefer for this type of problem. That's totally fine. You use whatever you like. Now, for the homework, they're specifically asking for point-slope form, so we'd want to go ahead and work with that. So let's remember what we have here. Our point-slope form is y minus y1 equals m times x minus x1. That is our point slope form. All right, how do we know? Because it's got the slope in it. Remember, m is the slope. And then our x1, y1, that's the x and y coordinates for a point on the graph. Well, the great news is we know 2 points on the graph. We only need 1, but we even know 2. So you can choose which one you want. It doesn't matter. Sometimes I get the question that says, well, how do I know if I'm supposed to plug in this first point or if I'm supposed to plug in the second point when we're actually plugging it into the point slope form? And the answer is it doesn't matter. You plug either one in. But first, we have to figure out the slope, and we have to do that in the right order. So we can call this first point x1, y1, and we could call the second one x2, y2, or the other way around. We could call this x2, y2, and this one x1, y1. That's totally legitimate. It seems weird at first. You go, well, wouldn't you get different numbers? You don't. You get the same slope either way. What won't work is if you call this one x1 over here from the first point, and then you call this one over here y1 from the second point, that's going to mess it up. So what I always do if I have to figure out the slope right above them, I'll just write x1, y1, and then above the second point, I'll write x2, y2. And then once you've labeled them, it's almost impossible to mix them up because you've got a label right above it, right? It's when people are trying to hold that information in their head that a mistake gets made. But if you just write it right here, you just label it, boom, you're not gonna get confused about which one's which. Okay, so let's plug these values in. We need to figure out our slope first, right? That's step 1, is always to figure out our slope. So we'll say slope equals, we usually call that m. And remember, our formula is y2 minus y1 over x2 minus x1. Is that showing up big enough? Yeah, that's big enough. Okay. So we've got our slope formula here. Now all we have to do is plug in our values from the problem. So let's see. We've got let's plug them in. So we've got -3, 3. So that's x1, and that's my y1. So let me prep this here. So my x1 is -3, my y1 is +3. So this is going to be 3, and my x1 is going to be -3. Now I'm putting this one in quotes or in parentheses because I'm actually subtracting a negative, so we have to be careful. We have to make sure we take our time with that one, right? So -3, 3, so -3, 3, and then 4 and -1. So that's my x2 and my y2. right here. So I'm going to plug those in. So my x2 is -1, my y2 is 4. So let's see if my y2 is 4. What do we say, -1? Yeah, -1. So I'm going to put that over here. -1. And let's see, what's that going to be? Well, 4 minus 3 is 1. And then -1 minus -3. Oh, did I make a mistake here? I might have messed something up. Let me double check here. But I think it might be coming out wrong. -1 plus 3 would be 2. But this doesn't, I think this isn't right. So I have to go back and double check my work here. What did I do? How do I know that I did this wrong? Well, this is, when we draw a line through here, it's going to be a decreasing line, right? So the easiest way to think about increasing and decreasing is think about a bank account, right? Would you rather have a bank account where the line is going up or where the line is going down? You want the line going up, right? Why? Because that's an increasing balance on your bank account, whereas going down is a decreasing balance. So we should be getting a negative slope. That slope is your rate of change. I should be getting a negative slope. I just got a positive slope. So I know I did something wrong. But see, that's the part of doing math well, is when something doesn't come out right, you catch it and you go, I made a mistake. So let me actually, part of this is because I'm teaching it and I'm not writing stuff down. So let me see here. As you can see, doing it in my head didn't work great. So unless I got them wrong over here, -3, 3, -3, 3, and 4, -1. Okay, so what did I do here? So if I write these points as -3, 3, and 4, -1, if that's x1, y1, x2, y2, then what did I do wrong here? Oh, yep, I think I mixed up my x and y. So it should be x1 is a -3, y1 is a +3, x2 is a 4. Oh, yep, I put those in the wrong place. So see, that's what I was talking about. It's easy to do this. So this should be my x2 should be 4. And my y2 should be -1. There we go. Let's see if that fixes it for us. Okay, so -1 minus 3 is going to be -4. And 4 minus -3 is going to be 7. Okay, at least it looks plausible now. So let's see if this makes sense. So this means, as soon as it compiles here, this means, remember, rise over run. We're going to go down 4 and over 7 in the positive direction. So let's see if that makes sense for our picture. If I'm here and I go down 4, 1, 2, 3, 4, and over 7, 1, 2, 3, 4, 5, 6, 7. Okay, there, I got it right. Okay, so see what I mean about not writing it down and having that label in front of you? It's easy to mix them up. I literally just did that because when I was trying to show you, I didn't write it down, made that mistake. Okay, good news is we've got our slope. We now know our slope is -4/7. So now we're going to go back to this equation we started with, and we're going to take this m and replace it with -4/7. Okay, so I've got my slope in there. And then the x1, y1, this part's easy. You just have to plug the points in one point from the problem. So pick one point and plug the coordinates from the same point in here. Should you pick the first point or the second point? Like I mentioned earlier, it doesn't matter. So pick whichever one you think is going to be easier, right? Some people pick the one with the fewest number of negatives, whatever. It doesn't really matter. So I will now take this and let's plug a point in there. And let's see, I'm going to think of it backwards. -3, +3. So the x is -3. So we're going to make this -3. And y was +3. Or y was +3. +3. Okay, so there is all the information plugged in, but this, it's weird. Most books don't ask for fully simplified point slope form. They usually ask you to put it in slope intercept form. So it's a little unclear what they would even mean by fully simplified, because I would argue that fully simplified would mean it's in slope intercept form. But for what they mean, I think we want to get rid of things like this minus -3. I think that's what they want us to address. We'll see. When I hit enter, I forget exactly what the form is. We can remind ourselves as I do it. So let's see. I would write this then as y minus 3 equals negative 4/7 times, this would now become x plus 3, because a negative times a negative is a positive, right? So I would argue that this is probably what they want. Let's see. So if we go back to, where's the problem? Oh, so y minus 3 equals 4/7 x plus 3. Let's see if they like that. Oh, incorrect. What did they not like? Let's see. Let me see. Let's look at the example so I can see. Well, they're giving us one that doesn't match. What do they want for fully simplified? Did they want it as negative? That's kind of a weird way to write it. Shouldn't that be right? Okay, let's double check this. Y minus 3 equals 4/7 x plus 3. Yep. Oh, because it's negative. Did I not put the negative in a minute ago? Oh, that's what it was, I think. So somehow when I hit the negative, I didn't type it, and then I copied it over without the negative. So that's my mistake. See how I dropped the negative from here to here? Now I'm putting it in. So this should be right. Let's try it again. Y minus 3 equals negative 4/7 x plus 3. Let me double check so I don't end up having to do a whole new problem. Y minus 3 equals negative 4/7 x plus 3. Submit answer. Yes. Yeah, okay. So I just left that negative off. I know students do that a lot. You can see it's an easy thing to do, right? Easy mistake to make. So, and you can see they did it the same way here. Same thing I did. What did they do first? They found the slope to get negative 4/7. You plug the point in, you simplify. Right? That's what you do for that problem. Now, so if I know someone asked about that problem specifically. That's a great problem. You're likely to see it on an exam. Know how to do that problem. Okay, I will probably have you, well, we'll see what I do for the test, but yeah, I'll just say make sure you know how to do that kind of problem. And if you can do that problem, you probably can do most of the problems in that chapter. So it's a good thing to work on. People definitely get confused about horizontal lines and vertical lines, right? So let's just kind of walk through it. I know a lot of times people try to memorize these. In mathematics, memorizing things generally means you're going to forget it within a few weeks. If you understand it, you'll remember it for the rest of your life. So let's remember that a vertical line is, say, x equals 2, okay? And a horizontal line would be like y equals 3. You go, well, how am I supposed to remember which one's which? How do I remember if x equals 2 is a horizontal line or vertical line? Well, think about the points. Let's mute this one for a second. We'll make that one invisible. Think about this line. This rule, x equals 2, is telling us that all the x values have to be equal to 2. Well, if you start thinking about points that you could make where the x values are 2, how are those going to line up? they're going to line up vertically, just like this. All these points right here have x values that are equal to 2. So if you just think your way through it, you go, oh, if all the x values are 2, like 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, yep, they're lining up vertically. Whereas if I have y equals 3, that's telling me all the y values are 3. The x value can be anything, but the y values are 3, and you go, okay, so this would be like 0, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3. Oh, yeah, they're lining up horizontally. So you can just kind of in your head think about plotting a few of those points and think about what makes sense there, right? So for those kind of problems, if you're given 2 points that are on a horizontal line like this, when you find the slope, you're going to get a reading that your slope is 0. And that makes a lot of sense, right? A slope of 0. Think about this. Like, this would be like level ground. If you were going on a hike and you were concerned that it was going to be maybe steeper than your health would allow you to do, and someone said, oh, there's no slope, the slope is 0, you'd go, oh, so it's like it's just horizontal. So it's an easy hike that we're going on, right? So that makes sense, that the slope of a horizontal line would be 0, and that's what you get when you calculate the slope. In fact, let's see if we can go back, because they had one of those. Let's go to the next problem, but I'll show you an example where they had that. Was this one? Nope. Here's a vertical line, right, which we'll talk about in just a second. Let me get back to a horizontal line. I suppose now it's not going to give me one. Here we go. Horizontal line, right? When you calculate that slope, oh, I was thinking they worked it out for us. When you calculate that slope, your numerator is going to get a 0 in it. That y2 minus y1, think about subtracting these -6 minus -6. You're going to get 0 in the numerator, meaning that your whole slope is 0. And that makes sense. That's what we think of. If I just asked you intuitively, what do you think the slope is of this? You might say, well, it doesn't have any slope. Well, it does have a slope. The slope is 0, right? The slope is 0, right? And that's what you get when you calculate it. That the vertical lines, in this case, it's a little weird, because in this case, what you get is 0 in the denominator. Well, we can't have 0 in the denominator of a fraction, so the slope of that line is undefined. We don't even have a term for it, and that's why that line is not a function, right? It doesn't describe a function. So the good news is most of the time when you're doing like a word problem, you're usually not going to come up with a vertical line. You could come up with a horizontal line. Those are fine. Think about it like as a bank account. Does this graph make sense as a bank account? So you go in on day 4 and you check your account balance and it's all these different values. That probably doesn't make sense, right? But a horizontal line makes sense. If we can get back to another one of those. This makes sense. This could be your balance for a bank account. It's at -$5 every day. Yeah, that makes sense. So you can kind of help remember, like, you using your logic and reasoning through it can help you figure out what makes sense for the problem. Okay, were there any other questions on that problem? That's a big important one. On the graphing 2 points, sorry, graphing a line from 2 points. No, we're good. Okay. The other thing I wanted to talk about was, where were we? Which time do we have? A few minutes. Let's see. What do I want to cover here? Let's do a little bit of function evaluation if there's no more questions, right? And as always, feel free to send me questions. That's how I know how to start the next class, is if numerous people have the same question, I can start with that topic. Okay, let's go into here. Evaluate functions. So let's do one of these. Okay, so I kind of talked about this last time, but I know some people are still getting used to functions. When you see g of 1, the g is the name. So that's just telling you use the function g. right over here. And you might say, well, why does it need a name? It's just that function. Well, you're going to be getting into problems that have more than one function in them, and you need to know which one is which, right? In the applied calculus, we use R, C, P for profit, cost, revenue, and you're talking about all those at the same time. You need to know which one's which, so you name it C, P, and R, right? So all this means is we take the 1 and plug it in here for x. So wherever there's an x, I'm going to put a 1 there. So when I plug in 1, I get -2 minus 1 is -3. So our answer should be -3. Yep, got it right. Okay, that's all you're doing. When it says evaluate or it says find this function value, you're just plugging that number in for x, and then you're simplifying things. That's all you got to do there. Students do get confused, though, sometimes where we evaluate functions from a graph or evaluate piecewise functions graphically. So another good place to watch the videos, but watch when we evaluate functions from a graph. So here's our graph. I don't have a function like I had a minute ago where I can plug the x value in, right? What we just did, where we take all the x values and we substitute in the given number that we're given, I can't do that here because I don't have a function value. I mean, I don't have an expression for the function itself. So it's saying find the value of f of 8. So what does that mean? Well, let's remember, this notation means we're taking an x value and plugging it into the function f. So that means that 8 is our x value, right? 8 is our x value. So what they're really asking here, but without specifically spelling it out, they're saying, what is the y value on this graph when the x value is 8? Okay, does that make sense to everyone? They're saying, here's an x value of 8, find the y value. So what I do is I find 8 on the x-axis right here, and then I go up, and that looks like our answer is 5. It has a y value of 5 because that point where the arrow is pointing on my screen, that would be 8, 5, right? So if the x value is 8, the y value must be 5. So let's plug that in. There we go. And you can see they give you a little box here. Yep, when the x value is 8, the y value is 5. So you just have to get your bearings on that graph. Once you're comfortable with the graph, many of these problems become very, very easy, but they're still a little challenging when you're learning your way around the graph. Okay? Let's just see if, let's try another one. So I'm going to give you a minute to look at this one. I'm going to give you a few seconds, see if you can figure this out, where it says find the value of f of 4. So I want to see if you're, those of you looking at it, can you tell what that answer is going to be? This is a good way to test yourself to see if you really understand what I'm talking about. So just take a second. All right, so this is telling me I have an x value of 4, and we want to know the y value when the x is 4. So I'm going to come up from 4. It looks like my y value is 2. Oh, sorry. This graph's a little small. Looks like I wasn't looking carefully enough. 4, looks like it actually goes up to 3. So my mistake, I was it's a little close here. So you got to be careful. Looks like the answer is actually 3. There we go. Got to look a little closer than I did. Up 4 over 3. Yeah, right. Yep. So some people are putting it in chat. They're getting it correct. Good. Good. Okay, where were we? Let's see. With stuff. Yeah, we have a couple minutes. Let's talk about piecewise functions, because piecewise functions tend to freak people out, and they're not nearly as complicated as people think. I think people overcomplicate them because they look scary. The notation is scary. They're different than other problems you've done. But actually doing them is as simple as what we just did. The last two problems where we substituted a value in or where we looked at the graph, you're going to do the same thing. So let's evaluate piecewise functions graphically. So what is a piecewise function? A piecewise function just means that we took different graphs and we just sort of glued them together. We made some kind of like Frankenstein graph by taking different graphs and just sort of sticking them all together and saying, here's our graph, right? We did that earlier. The very first problem we did today where we did that story problem and it was all these different lines. We had horizontal lines and lines going up and lines coming down. That was a piecewise function. In that case, we constructed it from the information in a problem. Here we're just given the piecewise function and we have to figure out what this is. But it's the exact same thing we're going to do in the problem we did a minute ago, except there's a little bit of a new notation. These open holes mean that the point doesn't exist there, but it exists right up to it. So, for instance, if we wanted to know what is the y value at x equals 6, it's this point right here because that's where the y value actually exists. You can have that. Sometimes people assume that graphs have to be continuous. Graphs don't have to be continuous. They can have weird jumps like this where it's coming down, it jumps up to this point, and then it jumps back down to this curve. That's totally legitimate, right? So in this case, they're asking me, what's f of -1? Well, I go over to -1. Look, there's no graph over here for -1. So what does that mean? It means it's undefined. Our graph does not have a definition at that point. Some people make this connection where if something doesn't exist in math, they go, well, then that must be 0 because 0 is nothing, right? That's not really right. 0 isn't nothing. 0 is a value. You can have $0 in your bank account. That's a defined value. Whereas undefined means, basically undefined means you've asked a question that doesn't make sense, right? It's like when you divide by 0, it doesn't make sense. It's not that in, like, people go, oh, well, why don't you just define it? Why don't you just come up with a definition for it? It's that it doesn't make sense. It's like in English, you can write a sentence that looks like a sentence, but when you actually start reading it, you go, oh, those are just random words put together. It doesn't make any sense. It's the same thing in mathematics. You can make something that looks mathematically correct, but when you look closer, you go, oh, that doesn't mean anything, right? It's the same thing here. So in this case, I would say undefined, submit my answer, and it would say correct. So let's try one that is defined because I want to make sure you know how to do that. Let's see, f of 2, it's another one that's undefined. Give me one that's defined. Here we go. This one should be, here we go. Find f of 6. See how this is a piecewise function? Because it's almost a horizontal line, but then there's this hole poked in it, and the value occurs up here. Okay, that's legitimate. That's a legitimate graph. So f of 6. So all that means is I'm going to find 6 on my axis. It's just like the one we did a minute ago that was not piecewise. We do the same thing. I'm going to find 6. Okay, here it is. My y value is -6. So I'm going to put that in there. -6. Submit. And it likes that. So graphically, these piecewise functions, no harder than the previous one. I think students get confused sometimes. Whenever you do a problem that makes you analyze a graph, just ask yourself, what are my x's, what are my y's? If you're always keeping track of your x's and your y's, then you can work through the problem relatively easily. Okay? Let me see. I've got 1 minute. Is there anything we should go over? Yeah, let's do this one real quick, or I'll at least give you an overview, and then we'll stop here. This is a piecewise function, but not from a graph. It's given in function form. But instead of, we're used to when we define our function, we just have one rule. This one has 3 rules, right? But over here on the right, they're telling you when to use which rule. If it's an x value that you want to plug in, this tells you when to use it. So they're telling us here to find f of 1. So 1 is my x value, right? So I have to ask myself, okay, which of these 3 cases fits when x equals 1? That 1 is less than 4, that 1 is equal to 4, or that 1 is greater than 4? Well, it's the first one. 1 is less than 4. That tells me I should use the top rule here. So I'm going to plug 1 into the top rule. So if I put that in there, I get 1. -2 is -1 squared is 1, making it -1. So our answer should be -4 because I plugged it into the top rule. Submit my answer. Hopefully I get that one right. There we go. And we got that correct answer. See how they have the top one highlighted? Because 1 is less than 4 for our x value. So don't overthink the piecewise functions. I think people let the piecewise functions kind of psych them out, and they get a little bit scared of it. It's not bad at all. And with that, I am out of time. So as always, when we finish class, I will turn off the YouTube stream. Anyone who wants to ask me a question is welcome to join me in the Zoom chat, and I will stick around until everyone has asked all the questions that they want to ask me. Otherwise, I will see you next week. Keep up the good work, stay on pace, and we'll see you later. All right, thanks everybody.